Hello, and welcome to another lecture in CIT 130, Introduction to Java Programming. Today's lecture, we're going to go more in depth into the idea of methods. Up till this point, we have made reference to this common line of code, something that has been common throughout every example we've done so far. Public static void main string args. This is the header for what we have referred to as the main method. Additionally, we have talked about when we have certain kinds of data types, which we call reference types, like keyboard, we can call or invoke methods off of those. Today I want to go a little bit more in depth, talk about both creating and calling methods so that we can really understand that concept. It adds a lot to our programs, and it will be incredibly useful when we start doing object-oriented programming in the second half of the course. So to start off, I just want to talk a little bit about the parts of a method. When we talk about, say, the main method, the first thing we have are what we call the modifiers. The most important here is the access modifier, public. We will find throughout this semester that methods are nearly always public. Making something public means that it can be accessed from other programs, other class files, if necessary. We'll talk about what the static modifier means once we get into object-oriented programming. For now, just understand that in classes that run, like this one, like everything we've done so far this semester, that all of our methods will be static. We'll go into great detail as to what it means and why it's a part of Java later on in the semester. So we have public and static are our modifiers. After that is a really important part of the method called the return type. In this case, it is void. Void is the return type when nothing is returned. The concept of a return, which we'll see in the example today, is really the idea that once the method is completed running, if it has a non-void return type, we are returning some data value back to wherever the method was invoked from. In this case, nothing is returned. Followed by that is the method name. In this case, it is main. That is a user-defined type like a variable. Methods use the same naming conventions as our regular variable data types. And in any program that we expect to be able to run through the Java virtual machine, there must be one method that's called main. Without a main method, the virtual machine doesn't know how to begin running things. It actually calls or invokes that main method from inside the virtual machine. The final thing is what we call the input or the arguments to the method, which in this case is the string args. So it's whatever is invoking the method must pass the required input or arguments to the method. The Java virtual machine, when it is invoked, it would send the string array of the args. So we'll look at on what that means in a little bit. So just hold on to that idea. But these four pieces are generally what we use for the header of a method when we write the method. Now, when we call a method, the method is either comes from the class, like the main method does, or like when we called the ceil or round methods from math in the last lecture, that was calling methods that were part of the class, static methods. Or we call them off of variables or objects of the class, like we do when we call things like next int and next on the scanner that we named keyboard. When we call the method, we use the name of the variable that holds the object, then the dot operator, which means I want something that is a part of that object, which is the next int method. Because that method is public, it can be called from this program into the code for the scanner. There is no input to the next int method, so we just use the parentheses to indicate we're calling a method, but we're not actually passing it anything. And we can see that by going into our Java documentation. If we go down to the java.util and we pull up our scanner and we go down to the methods for that scanner, we'll see that next int has no arguments. What you'll also notice is this part over here. We haven't talked about this yet. This part over here is the return type. So what you'll notice is some methods say void there. Some methods have non-primitive types like string. Other methods have a primitive type like Boolean. So we can return any type back from the method, and we'll see that as we move through the example today. So before I jump in to writing our own method, we generally refer to methods by talking about a method signature. This is just a way of referring to the method in a more generic way rather than a coded way. The method signature is it consists of three parts: the name, the number of arguments, and the types of arguments. When we get into object-oriented programming, this is going to be very, very important. But for now, The reason we define the signature in this way, you may be thinking, well, isn't the return type an important part of, say, the signature? The reason it is not is because when we call a method, we how we call it is based on the signature. The return type we need to know, which is what makes it the documentation, very useful. But knowing the signature helps the computer, the Java virtual machine, to know what you're referring to here. It refers to this by the name, how many arguments there are, and what the types of the arguments are. We'll see the real importance of the method signature when we get into actual object-oriented programming. So hold on for just a couple of weeks on that, and we'll talk about it more. So besides the main method, sometimes it makes sense for us to create some other kind of method. One of the things that may have occurred to you when we were working on this example originally was, yes, it's nice to know whether the number is positive or negative, but isn't it more important for us to make sure it's a number at all? So what we can do is we can create a way of looking at the what comes off the keyboard to check whether it's a number or not a number. And what I mean here, if I go in to do to look at the example as we did it last time. Oops, CIT 130 examples. What we see, and this one is movie tickets, no negative. What I'm going to do is I'm going to rename movie tickets.java to movie tickets string math, which is the last version we did. And I'm going to save this as just movie tickets so that it will compile. Remember, the name of the class must match the name on the class file. So what we'll do is we'll do javac movie tickets.java. Java movie tickets. One of the things that you'll notice is right away, if I typed in that there are 3 persons in our party, the program crashes. So yes, we introduced the idea of data protection, but we really want to take it a step further than what we've already been able to do. With what we learned last time and expanding it to this with this idea of the method, we're going to be able to do something even better. So what I am going to do is I am going to introduce a string variable, and I'm going to call it input. And what I'm going to do here is I'm going to, instead of taking an integer off the keyboard, I'm going to just take it as a string. For now, we're not going to assume that they're going to put spaces in it. we did talk a little bit about working with that last time using the next line. In this case, I am going to just use the next. And what I want to do here is I want to be able to see if that's a number. It's going to take more than just one line of code for me to determine whether the string is numeric. If they type in a single digit number like 3, it can be a lot simpler, but we just want to be able to make a method that's more flexible than that can determine if, a multi-digit number, which if read in as a string, if it's completely numeric. And in this case, the way we're going to write it today, it's also going to help us determine, we'll also know that it's a positive number as well. So we're going to kind of kill two birds with one stone. So what I want to do is I'm going to jump down. Down here, this close bracket is the end of the main method. And what we're going to do is we're going to do public static Boolean is numeric. And we're going to have that take in a string that we're going to call input. What we're going to do with that string input is we are going to check if each character within the string is a number or not a number. So how we can do that is we can do a deterministic loop. We can say for int x equals 0, x is less than input dot length. That is the method that we use to determine the length of the string, and then we do x plus plus. So there, what we are doing is we are going to loop over the entire string. And what we'll do is if input dot char at x, remember char at will tell us what the character at any given spot within the character array that makes up the string is. So that is going to return a character. So what we want to do with that character is we want to see if it is numeric or not numeric. So I'm going to introduce an additional topic here. We've mentioned it, I believe, briefly in the past, but I really want to solidify it now. Inside of the java.lang package, there are a series of classes that correspond with each of our data types. The one for cars is called character. And one of the things that we'll see if we go down to our methods is that there is one method that says is digit. that takes in a car. Now, one of the things that I'm just telling you for now, again, is when you see this static, you know that I call it from the class. That's really what that means, but it'll make a lot more sense once we understand classes versus objects in a much clearer way. So what I'm going to do is I'm going to use the character class and call the dot is digit method, and I'm going to pass it input.car at x. So that returns a Boolean, as you saw. Is digit returns a Boolean, which basically says if this is a 0 through 9, if it's a digit, then return true, otherwise return false. So what you see here is if character is digit, meaning it is a digit, we want to do something. But in this case, we actually want the opposite of that. We only want to stop looping, finish out our operation if the character is not a digit. So if it is a digit, we don't want this if statement to fire. We want it to continue to loop. So what we'll do there is if it is not a digit, then we will print, and this is calling a method called printline that says please enter a valid positive number, so that they understand that they've made a mistake. And then we're going to introduce a new keyword here called return. And what we'll do is we will return false. So what happens when the return statement is found is it will go back to where the method was called from. Now, I haven't called it yet at this point, so we'll look at that in just a few minutes. So at any point, if it finds something other than a number, it will print out the message and return false. If it makes it all the way through the loop and never finds a non-digit, what it will do is return true. So we have a concise set or block of code inside of this method. So what we can do with that is up here, is we can say, I'm going to remove this temporarily. If is numeric input if not is numeric, we've already printed our message, so I don't need to do that here. So what do I want to do? Well, really, I just want I want to loop again. So I actually can make a much more concise operation here. I can actually change this to while the input is not numeric. So what we'll do is they'll type something in. If it's not numeric, it will produce the error and then ask them to enter again, and it will continue to do that until something numeric is produced. But now we have one more thing to do, because now we know that that it is numeric. So now we want to store it inside of party size. But remember, party size is an int, input is a string. Going back to our classes, what they call wrapper classes for our primitive types, we have the integer type that goes with int, and we'll notice, if we go down, that there is a parse int method that is static. I call it from the class, and it returns an int. So what I'll do here is I will do integer dot parse int input, because that took in a string. So when the string is sent to parseInt, it returns an integer that is the integer of the what they typed in. And we know it will work at this point because we did this checkup here. We wouldn't have got as far as we are if they had not entered in a valid integer. So, going with that, we now have something that's more concise and more inclusive. So, you'll notice all I do to call the method is invoke its name, is numeric. I don't have to put anything in front of a dot because it's part of this same class file. So I'm actually calling it right from inside of the same program, so I don't have to use anything with a dot to invoke it. And remember, it was expecting one string input or argument, and so I send it what came in off the keyboard, and what happens is as soon as it calls that, the execution jumps down to here. Now, we happened to name the variable above and inside this method as input. That will not always be the case. We will see many times later in the class where they don't happen to have the same name. Remember, variables have scope from where they're declared to the end of the block. So in this case, this input only is valid inside the main method. When we put an argument in the header like that, that is equal to a declaration for it, and input is valid inside the entire block of code that defines that method. This input is different than the input in the main. They just happen to have the same name, but because the scope is different, one of them has a scope in the main and the other has scope inside of is numeric, that's legal. Anytime a variable lives in a specified scope, we don't have to worry about using a similarly or same named variable in another scope. So when it came down here, whatever they typed at the keyboard is sent as a string here. And what it does is it checks each character within the string individually to see if it is a digit or not a digit. If it's not a digit, it will print an error message and return false. If we return false, the while statement is true. The not flip-flops it from true to false, from false to true, so that we redo the loop and keep asking them to enter until it comes out something numeric. Once it's something numeric, we know we can call integer.parseInt on it, and we'll be good. And now party size will be what party size is, and we can go through the next part of the operation. Let's see how that works with at least the example we've done so far. I forgot a close parenthesis. Where was that at? It's on line 98 of our code. So let me go down to line 98. And what it says is if character dot is. So you'll notice there's an open paren and close paren for the car at method. There's an open parenthesis and a close parenthesis for the is digit method, but there's not a close parenthesis for the if statement. It's a very common error. It's good to see it in practice because you will likely do it often on your own. So let's go back and rerun our movie tickets program. And now let's try typing in 3 as a word. And what you'll see is, please enter a valid positive number. Well, let me try -3. Please enter a valid positive number. Now, what you may be thinking is, well, -3 is an integer, but the is character method that we're using checks each character in the string. This is a 2-character string. The first character is a negative. The second is a 3. It's actually checking, and as soon as it saw that minus sign, that isn't a numeric digit. It's not a 0 through 9, so it's simply saying that. And the other thing that's cool is if we said like 3.3, we're going to get the same thing as well, because while 3 is a valid digit, the decimal point is not. So this is numeric that we wrote back here actually is really, even though I called it is numeric, is really checking to see if it is a positive integer or a whole number. I'm counting 0. So it's actually includes a lot more. So now we have a much more what we would call robust program, so that I can finally, when I type in the people, I get the expected results, and we get a ticket price because it looped 3 times. So one of the advantages of a method like is numeric here is that it is repeatable. If you look back up here, when we did the age, we did a similar thing to what we did up here. So, how old is the person for the next ticket? Well, let's use input instead of age, and next instead of next int. And now, what we can do is remove that piece, and instead of while age is greater than 0, we can say as long as it's not a numeric, as long as input is not numeric, continue this loop. And you'll notice, I kind of hinted at it, but you'll notice the second advantage of using methods, which is readability. So what we've done here is basically ask how many people are in the party, take it off the keyboard. As long as what they enter is not numeric, keep asking. In addition to it being reusable, it's very readable. How old is the person for this ticket? Input keyboard.next, while not is numeric input. Keep looping. And one of the things that you'll notice I did intentionally is I said, please enter a valid positive number. That way, no matter what kind of data they're entering, it means the same thing. I'm actually going to change it to positive integer, only because since it does not allow floating points, which makes sense. We're not doing ages that way, and we're not doing number in the party that way. So I'm just changing it, making it even more focused. Let's recompile it. Oh, I forgot one piece. We checked it, but then we did not put it in. So we need the age equals integer dot parse int input line. Just like we did up here with party size, we need to do the same thing with age. Just forgot that line because I was focused on the method. Let's compile it again. Should work good. Let's go ahead and run it. So if I go and try to type in 3, but I accidentally hit the E as well, it's going to say enter a valid integer. Oh, sorry, I meant 3. How old is the first person? Well, my child is really proud of their half, so they want to be 5.5. Well, please enter a valid positive integer. Oh, okay. Well, sorry, we're going to have to go with 5. How old is the next person? We do that. And if we went for the next one, again, let's just say we accidentally hit a character in there. Oh, it doesn't do anything, so we go ahead and put it in right. Everything stays the same. So what we have done is we have made something readable and reusable. And one last advantage is what we've done here. You see that is on the order of 8 to 10 lines of code. We turn that into what we would call an atomic operation or a single command, which goes back to the point of readability. But turning something complex into an atomic operation just helps simplify the code so that it's easier to work with, easier to read, easier to debug. So those are just advantages we get from working with methods in this manner. So that is an introduction to methods. Understanding that main is a method that we've been working with all semester. We can create other static methods that take in some kind of input, produce some kind of output, and inside of the method, we are dealing with a set of code that is reusable, creates a single atomic operation that when we invoke it or call it from another place, makes our code more readable. So that is a summary of methods. The next lecture will cover arrays before moving into object-oriented programming. I hope that you got something out of this and that you're able to use it in your own coding. Take care.